Let's talk about annuities. An annuity is an account in which interest is compounded and we make regular deposits or regular withdrawals. So a couple of examples is you could just start putting money into an account, and maybe every month you put money in, and that account gives you interest and compounded interest. And of course, as time goes on, the account grows both because you're putting money in and because the money is accruing interest. And so that makes it an annuity. Or you could have, in the other way, you could be taking withdrawals. You could have a large amount of money in an account that makes interest, but you regularly take money out of that. And so while it shrinks because you take money out, it also grows because of interest. So those are examples of annuities. So we will start by talking about savings annuities. So a savings annuity is when you make regular deposits into an account that gets interest. And this formula here, it tells you how much money will be in the account, and that amount is what we call P of T after a certain amount of time. So let's talk about the different things in this very fancy equation and what they mean. We'll start with the P of T right here. Okay, this is the amount. Okay, amount in the account after T years. Okay. And then we've got this whole thing over here to deal with. So we've got D, okay, and D is the size of the deposit, size of the regular deposits, I should say, regular deposits. Okay, then we have over here, we've got R, and R shows up in these two different places here, and R is the interest rate, the annual interest rate, I should say, annual interest rate. Okay, and in other words, that's the APR. Okay, and make sure that that is in decimal form. Okay, and it's both in both of those spots. Okay, then we've got N, and N shows up in these three. Oh, let's not mess up that T there. Okay, so we've got N there, and we've got it here. So in three different places, we've got N, and N is the number of times compounded per year. Number of times that interest is compounded per year. Okay, and then finally we have we've got this T right here, and T of course is the number of years. Number of years. All right. Now, one important aspect that's not stated here explicitly in the formula is that this N, the number of times compounding per year, that actually also has to be how regular our deposits are. Okay, so if we compound monthly, then we need to be making monthly deposits. Or if we compound quarterly, then our deposits are quarterly. Okay, so the time frame for our deposits must match the time frame for our compounding. So let's look at an example of a very common type of savings annuity. That is an IRA. So an IRA, this is an individual retirement account. It's a special type of retirement account in which the money that you invest is exempt from income taxes until you withdraw it. Now that's nice because if you pay tax on that income, then you don't have that amount that you would pay in taxes to put into the account to make money to get interest on. And so you don't have to pay the taxes on it until you actually pull it out and you want to use it, in which case that interest has had a lot of time, or sorry, that amount that you would have paid taxes will have years to grow in interest. So suppose you deposit $100 each month into an IRA earning 6% interest. how much will you have in the account after 20 years. Now, it says 6% interest. It doesn't indicate the time period on this, and we will always assume, if it doesn't state the time period for our interest, we'll always assume that that is an annual percentage rate. So this is the APR. Okay. All right, so we're going to use our annuity formula. We'll go ahead and write it down. P of t, the amount of time that we have, is equal to d times 1 plus r over n to the nt minus 1 over r over n. And this is going to tell us how much we have in the account after a certain amount of time. So let's go ahead and just plug in everything that we know. So P sub t is 20 because we want to know after 20 years. Okay, D is the deposit amount. Okay, and so we look here and we see if we're depositing $100 each month. Okay, so D is then 100. That's our deposit size. And then we've got 1 plus, and then we've got R, and R is the rate, the annual rate, and that was this 6%, and so that's 0.06. Okay, and divided by n. Now n is the number of times compounded per year. So what we need to do is actually go over here and we see that our deposits are every month, and so that's going to assume then that our compounding is also every month. So that is 12 times per year. And that n shows up right up here as well, 12. And then times t, and t was 20, okay, because we had 20 years. And then we had minus 1, and then this is all over, and then r over n, which is the 0.06 over 12. All right, so lots of things going on in this equation, but we actually can just now plug that into our calculator. So we've got 100 times, and be very careful with your parentheses and stuff. Some calculators will have a nice display where it'll show you the fraction kind of as you're creating it, and everything is as you expect in formatting, and that's really nice. Okay, and then we've got minus the 1, and then we divide by 0.06 over 12. All right, so that's a nice big fraction there. And this value that we get, you're always going to want to round this to 2 decimal places because we're talking about money, and so we have to round it to the nearest cent. And so we're going to have our 46,204, and then rounding this to the nearest cent is going to be 9 cents. So this is the 46,204 and 9 cents.